So this lesson, 82, is all about evaluating functions and domain and range of functions. So let's talk about what a function is. We often see function with the notation f with parentheses x, and we actually call that f of x. Now, when you're first learning about mathematical symbols, you might think it's multiplication, but it's not. It's not f times x, it's just a notation that means there's a function that has x's, inputs, and then outputs. You'll also see things like g of x, h of x. Those are the most common ones you'll see. And so we've seen this notation before, but now we're going to get into really what a function is. So before I do that, we're going to evaluate functions. So f of x equals 3x squared plus 2. This is an example of a function. Again, this is not f times x. This means there's a function that has an input of x, and this is the expression that tells you what to do with that input. So every time you put in a 1, you would say f of 1, you would get 3 times 1 squared plus 2, which is 3 plus 2, which is 5. And that can be, so the input is 1, the output is 5. You can plug in any number. You can plug in a 2, a 5, a negative 10, and you can calculate what is your output based on this expression. So now we're going to get a little bit more complex with it, and we're going to put in actual expressions instead of f of x. So we know that f of x is this. So if I want to find f of b squared. So this is the definition of the function. This is what we need to do to it. So f of b squared is just 3. I'm going to replace the x with b squared. And when we replace things, we like to put them in parentheses. And so all I did was replace the x with the new input. The new input is b squared. Now I can simplify a little bit. 3 times, this is going to be b to the 4th now, because we multiply the exponents, plus 2. And so this is the output. So sometimes the output is not a number, but an expression. So this is the output that's an expression. So let's do another example like this. So if I have f of x equals 2x squared plus 3x plus 5, and I'm asked to find f of a squared. F of a squared. So to find f of a squared, I'm going to do the same thing, just replace every x with the a. So 2, instead of x, I'm going to put a squared, and then I have to square it again because I just replaced the x, plus 3 times a squared, which is my input, plus 5. Again, we're going to simplify and get an expression here, not a number. So 2 times a to the 4th, when we multiply exponents, plus 3 times a squared plus 5. This can't be simplified because there are no like terms, so this is the output when a squared is the input. Okay. So that's how we do evaluation of functions, just substituting in the input. And now we're going to talk about what is domain and range. So domain and range can be confusing when you're first learning them. So the domain of a function is just telling you about the inputs of the function. So I'm going to look at a graph, and the reason why is it's going to show us what domain could look like. So there's the y-axis and the x-axis, and a lot of times instead of y, we'll see f of x is kind of the same thing as y, so the function of x. So the input, x is always the input value, and y, or f of x, is your output. And so let's take, for example, a line. If I'm going to graph the line y equals 2x plus 3. So we've learned about graphing, so put some tick marks here. And 2x plus 3, I'm going to start at 3. When I graph this, we learned about slope-intercept graphing, so I'm just using that method. I start at 3, and then I use the slope, which is 2. The slope is 2, so that tells me every time I go up 2, I'm going to go over to the right 1, because it's 2 over 1. So I could also go down 2, and over to the left 1, and so on. And I can graph this line. So, looking at this line, we can consider this line a function. So the line is 2x, y equals 2x plus 3, but it's actually the same thing as f of x equals 2x plus 3. So 2x plus 3 is the expression that tells you what the function does. So the inputs are the x values. And that's why when we make an xy table, we have an input, we choose the value of the input, and then we calculate the value of the y, or the output. So xy table could also be a x f of x table. So anyway, we're going to talk about what the domain and range mean. The domain of a function is just all of the possible input values. So for example, if I'm looking at this particular function, this line that I've just graphed, the x values, they could be anything, because I could keep going further to the left, further in the negative x direction. I could keep going up and further to the right in the positive x direction. And pretty much I'm never going to stop. I could have any possible x value could be a part of my domain. So the domain for this is going to be x is a real number. And that's it. It's a real number. There's no restrictions on this domain. The range is all the possible values of y, or the output, or f of x as we call it. We put in an input and we get a certain output. So the y's, you could keep going up forever and you could keep going down forever. And there's really no restriction, because this is a line, a function of a line, a graph of a line, and we know that lines go on forever. So the range is also going to be y is any real number. Now, not all functions are going to look like this. They're not always going to be lines, and they're not always going to be all real numbers. So let's look at an example of a function that's not all real numbers. So sometimes functions can stop, right? They can stop at certain points. So let's take this function here. Let's say this is the point, this is 3, this is -4. And I'm going to put an open circle there. And then I'm going to put a funny shape and put a closed circle here. And let's say that's the point 3, -1. So as we can see, this function is a weird shape. It doesn't go on forever in any direction, so it's got limits on it. And the limits are going to be the domain and the range. So the domain, write d equals, I'm looking for the limits of x. What's the smallest possible x value I can see on this graph? If I go all the way to the left, there's no arrow. It doesn't keep going. It stops right here. And so this coordinate is -4, 3. So the x value of this coordinate is -4. I'm going to draw a little dotted line here to show that this is the limit. This is as far left as you're going to get. And then the highest possible x value is going to be the most far right I can get. So the most far right would be this. And the x value here is 3. So the x's are in between -4 and +3. So how do I write that? I just say x is a real number such that -4 is less than x is less than 3. So I'm writing a conjunction. Now I just have to be careful with the less than or equal because -4 is an open circle, so I'm not going to underline this inequality symbol, but +3 is a closed circle, which means +3 is included in the domain. So I'm going to put less than or equal to on the second inequality symbol. So that's the domain. Now let's talk about the range. The range is also going to be written the same way. It's going to say y is a real number such that. So now I'm going to look at the top and the bottom of the function. If I look at the highest possible y value on the graph, it's going to be right here. And the y value of that is 3. And then I want to find the lowest possible y value, which would be down here. So you can draw a dotted line here. And that would be, let's say, I didn't define that yet, but that's a -3 here. It's -3 is its y value. So now I'm looking at the upper and lower limits on this, so that's -3 to +3. So how do I write that? I just write a conjunction, same thing. I say -3 is less than y is less than +3. And then I make sure to underline the ones that need to be underlined. So in this case, the highest point, it's an open circle, so I do not underline here. But the bottom, although there's no circle here, this part of the graph is black, there's no circle, so we assume that -3 is included, so I'm going to underline that one. So this is my range, and this is my domain. Now, one more example for domain, and this is an example that confuses people sometimes, but we're going to take a look at it. So 1 over x, let's say f of x equals 1 over x, and let's say g of x equals the square root of x minus 3. So we have two different functions here, and I want to figure out the domain of each function. So the domain is all the possible values of x. So if you look at this graph or this function, you can say, okay, what can I put on the bottom of this fraction? What can I replace x with? Would it make sense if I replaced it with 2? That would be 1/2. If I replaced it with 10, it would be 1/10. If I replaced it with 50, it would be 1/50. So what number would not make sense? So I want to think about the number that doesn't make sense here. The only number that doesn't make sense at the bottom of a fraction is 0, right? If x is 0, then the whole thing doesn't make sense. There's a 0 on the bottom, it's undefined. So how would I write that? I would say the domain is x is a real number such that, let me put my brackets here, x is a real number such that x is not equal to 0. So I'm going to put an inequality here showing that x can be pretty much anything but not 0. So then the same kind of thing applies here. What could I put in x that would make sense, or what could I put in x that doesn't make sense? So we know x is a real number such that. So what number would make this not make sense? What can we not put under a square root? Well, if this number is negative, it doesn't make sense. You can't take the square root of a negative number. So I'm going to say x minus 3, the thing under the radical, must be positive. Which means x minus 3 must be greater than or equal to 0. Because we can take the square root of 0, but we cannot take the square root of a negative number. So now figuring out what x can't be, this is just like an equation. I can add 3 to both sides to get x by itself. And I see that x is greater than or equal to 3. And this makes sense because if x is 3, 3 minus 3 is 0, we have the square root of 0. If x is 4, we have 4 minus 3, which is square root of 1. If x is 5, we have 5 minus 3, which is the square root of 2. All these numbers make sense. But if we have something smaller, like if x is equal to 1, 1 minus 3 is negative 2. So it doesn't make sense. So as long as x is greater than or equal to 3, the domain makes sense. It works.